Um, Happy Friday, everyone. As always, if you want to drop your name and affiliation in the chat, we can all say hi to each other there. And it's great to see you all this afternoon for me on the East Coast. Okay, so we will go ahead and get started. So a reminder, we always give you a little reminder about who we are. So we are a national effort based at Stanford to build a national network using consistent methods for monitoring diseases through wastewater. Allie and myself are the program directors, and we work with Verily and NLC, and then all of you who are here today on this call from Public Works, wastewater officials, public health, and other leaders to actually make this program happen. So welcome, and we just want to say again how thankful we are for all of you and your partnership on this project, because we have learned so much about the use of wastewater monitoring in this project and are really happy to be able to consistently share this monitoring data with you. Just a quick program overview. So where are we at this point? So right now we have 191 plants that are sampling, and those sites represent 13.5% of the US population across 41 states. I know we've gotten a lot of questions certainly about the future of the program, and what we did want to kind of share with you today is that we have, with our current funding, the ability to continue with all of our sites through the end of June. And then we're currently figuring out what the next phase will look like, and we'll communicate that to you as soon as we have more concrete information. Right now, what are we currently monitoring? So we have our important seasonal and emerging respiratory pathogens, SARS-CoV-2 and influenza A and B. Allie will give us a little bit more of the update on influenza A in a couple minutes. RSV, human metapneumovirus, EVD68, and human parainfluenza. We have for enteric pathogens, rotavirus and norovirus G2. A reminder that we did remove adenovirus from the panel in order to address some of the challenges we had with influenza A. And then our emerging and outbreak pathogens of concern, Candida auris, hepatitis A, and Mpox. We also now have sequencing data on the dashboard, and so we'll share again about that in a minute. We've showed it a little bit before. We now also have a national, or all of the sites that we have sequencing data from overview on the dashboard. So that's a great place to look and get kind of the overview. Again, it's not every single site within the WastewaterSCAN network, but a little more than 30 sites that we have sequencing data from. So here is what that sequencing data looks like. It's whole genome sequencing from wastewater solids. We're using a tiled amplicon approach, and then using Freya for the bioinformatics. We have a protocol that's available on protocols.io, so you can view all the details of how we're producing this data there. And the data is available on our dashboard, data.wastewaterscan.org. This view here is the nationally aggregated view of the data. So this includes the data from all of the sites that we're currently sequencing, and you can see that this very large red bar section in the most recent data is JN1, which is definitely what we would expect after a very kind of quick explosion onto the scene. The majority of what we're seeing in wastewater right now is JN1, and you'll see that the first time that we detected JN1 using the sequencing approach, the first time it shows up was back here in kind of mid-November. Each one of these bars represents 2 samples per week from the sites that are included in sequencing. All of our protocols are publicly available, and so you can scan any of these QR codes. We send out these slides so you can scan them later if you'd like to take a closer look at them. For all of our methods, and then some more information about the measurements that we're making for all of the different pathogens that are included in the program right now. And now I'll pass it to Allie to talk about the wastewater categories.
Good morning, everyone. So as you remember, we have started categorizing the wastewater based on information on the trend, level, and frequency of detection. And this was motivated by a lot of questions from you all, as well as the public and media, about what is happening in wastewater, and trying to communicate that accurately without being so complicated that people didn't understand what we were talking about. So the trends tell us how things are changing, if they're increasing or decreasing. The levels tell us whether levels are high or low relative to the historical data. And frequency is how often rare targets are detected in wastewater. So we have identified 3 archetypes for our WastewaterSCAN pathogens. The first are pathogens that are commonly detected regardless of season, such as SARS-CoV-2 and norovirus. Another archetype are seasonal pathogens that are rarely detected outside of their season or outbreaks. That includes influenza, RSV, human metapneumovirus, EVD68. And then I don't know why it says soon there. We should probably delete that. And then pathogens that are not commonly detected, regardless of season, would be something like Mpox. I know why EVD68 says soon. It's because soon we are hoping to turn on a category for EVD68, but we don't currently calculate a category for it. And we don't calculate categories yet for parainfluenza, rotavirus, C. auris, or Hep A, because we're still learning about those levels and trends in wastewater. So let's look at the current wastewater categories. These are all calculated with data that we have processed through February 6, 2024. This is an overview of all of the different pathogens that we're providing categories for. In the table is the list of pathogens that we're currently calculating and their wastewater category nationally, and the explanation for why they're in that category. So the bottom line is that every pathogen is in a high category except for human metapneumovirus and Mpox, but they're in the high category for different reasons. For SARS-CoV-2, as you can see in the plot over on the right, levels are still relatively high, but they do have a downward trend. And when concentrations are in that state, they still receive a high category according to our algorithm. For influenza A, which I'll talk more about in a bit, it's also high because more than 50% of all sites in the nation are in onset. Although there is a downward trend, there are still relatively high concentrations. Influenza B, shown in the next plot in the middle, is also high because more than 50% of all sites in the nation are in onset. It has still an upward trend and a relatively high concentration. RSV is in a high category, again, for the same reason as influenza A, where more than 50% of the sites are in onset. There's a downward trend, but still a relatively high concentration. And norovirus, I'll skip ahead to that one, is also high. It currently has an upward trend and a relatively high concentration nationally. Human metapneumovirus is the only plot shown here in low, and that's because less than 50% of all sites in the nation are in onset. So we'll look a little bit more closely here. Here are the SARS-CoV-2 aggregated concentrations in the different regions of the United States, and they look quite similar across regions. Relatively high concentrations over the last 21 days. The median is over 200,000 copies per gram. And we can see that levels have been decreasing since that peak that we had in sort of the very beginning of this calendar year. Marlene already showed this plot earlier, so I won't spend too much time here. I did want to address a question that did come in through the question form that we submit to you. Why is the data missing for those 2 dates in mid-December? Those samples are still undergoing our QA/QC process, so we haven't included them yet in the aggregated plots. So those we'll have more information about those soon. And then I also want to point out that the sequencing data are always 1 to 2 weeks lagged because it does take time for the laboratory to run the results and then run them through the bioinformatics pipeline. So as opposed to the digital PCR data, which comes sort of instantaneously as soon as we get the samples, this will always be a little bit behind. And this is pretty consistent with even clinical sequencing data, which is also behind. And here's our map that you can see on our website showing the entire country in a sort of peachy orange color, indicating that nationally all regions are in a high category for wastewater. This is the plot for RSV. We already looked at the wastewater plot in the overview slide, but what we've added here is the positivity rate data from CDC, which is strikingly similar in shape. Positivity rates are also decreasing, although we'll note that the clinical data are only available through January 27th, publicly available. And it's probably a bit incomplete because the data can still be submitted from the Sentinel laboratories that participate in the NERVS program. Over the last 21 days, 88% of all samples received by WastewaterSCAN were positive for RSV. And here's the RSV category map, also showing all of the regions in aggregate are in the high category, but there are some sites that are already in a low category, suggesting RSV season has ended, particularly in the South and some locations in the Midwest. Here are the influenza B data, alongside also the data from NERVS at CDC. Also strikingly similar between the wastewater aggregated national data and the national aggregated positivity rate data. Same limitations with this clinical data for influenza B as for RSV. And we are seeing the majority of samples coming into the lab in the last 21 days positive for influenza B. And if you remember and look at our historical data, this is kind of a different picture this year than last season, where there was very, very limited influenza B circulation. And here is our influenza B map showing all regions in the high category, except for the New England region. And you can see individual sites are, range from low to high. I want to address the influenza A data. So last time we met, we explained how we identified a performance problem with the influenza probe, and that the fluorescent molecule used on the probe, which is a very important part of the digital PCR process, was not fluorescing as it should. We replaced the probe. We replaced the fluorescent molecule on the probe with a new one, and it's performing well. We've done a lot of testing with it, and we're currently running samples with the new probe. There was a question submitted, like which vendor did this come from? It's not a vendor issue or a kit issue. We don't use kits. We actually order all of our primers and probes custom from IDT. It wasn't as far as we know, a synthesis problem. It was simply a problem with a new type of fluorescent molecule that can be used with some of these newer instruments. So there wasn't a kit. There's no warning going out about a specific kit or anything like that. So I wanted to make sure that was clear. We did remove all the impacted data from the website, which was approximately October to January. But we have rerun 2 samples per week from all the sites to retrospectively replace the impacted data. And the data that have been rerun are now available on the site, and retrospective analysis is nearly complete. So we have a few more samples to upload. And we have confirmed that the data that has been processed retrospectively is directly comparable to the samples that are being run prospectively, so that we can look at the peaks and compare data between samples that were run retrospectively versus prospectively. So if we look at the next slide, we can see what the data look like nationally aggregated right now on the WastewaterSCAN site. So you can see now that we can see our peak that occurred in influenza season right around the new year, that levels are declining. And then we see this missing period just sort of at the beginning of October. And those are the last set of samples to be rerun and added to the dashboard. The data here may look a little more jaggedy just because we're only doing 2 samples per week for the sites. We're not doing all the samples because of just sort of lab throughput and cost associated with retrospectively rerunning these samples. But we're really happy to have the influenza data back online, and the categories have now been turned back on the website. So we're good to go on that. Here are the data on human metapneumovirus. Same overview plot, nationally aggregated wastewater data, and then the data from NERVS at CDC on positivity rate, showing a similar pattern to the wastewater, a relatively low occurrence of human metapneumovirus right now, especially compared to last spring. So we'll have to see if human metapneumovirus gets its go this respiratory season or not. Less than half the samples that have come into the lab over the last 21 days have been positive for human metapneumovirus. And here's our category map showing the nation and regions in a low category, and just a couple dozen sites that have actually onset of human metapneumovirus season. Second to last pathogen here is good old norovirus, which I hope I do not get anytime soon, showing the wastewater data aggregated across the country, and then the data from NERVS again on positivity rate from Sentinel Laboratories, showing quite similar patterns to the wastewater data, with the same limitations, of course, as the clinical data for RSV and influenza that we've discussed. Concentrations of norovirus are always relatively high and detectable in wastewater. The median over the last 21 days was over 9 million copies per gram of norovirus G2. And here's our category map showing the nation and all regions in the high category. Lastly, we have Mpox. We've had very few detections of Mpox. Only 3 samples of over 1,300 samples run in the last 21 days have been positive. We find that the Mpox data are still important to many of our public health partners, so we do not plan to sunset this assay, regardless of whether there are cases or not. We do want to say that this assay detects the clade 2 Mpox. It's specific for that. And this heat map shows the results from region 7, HHS region 7, and you can see just one little detection in Coralville. And with that, I'm going to be passing it to Marlene to give you a couple website updates.
Okay, so again, we'll send out these slides. So if you want to go back and look at any of that information that Ali just shared, it'll be there for you. And of course, it's also all on the website. So one kind of new feature that we have found incredibly useful internally, and I hope some of you will appreciate as well, is that you can now easily see the count of plants in each category, and you can also, for small regions, get a list of plants in each category. So outside of the national level and then the larger regional, 4 regional level, we're not calculating aggregated categories. But if you go to the bar at the top of the dashboard where you can select between nationwide and each of those regions and click others, you will then be able to select one of the other groupings that our data is available by. And then you can look, and it will look like this, and it will show you how many of the sites in that region that you selected are high, medium, or low. So you can see here, if I've gone others and I've clicked Georgia, then this is the view that'll appear. It'll show me for each of those that we calculate categories for, how many of the Georgia sites are in each of those categories. And if you click the little I information, it will show you which sites those are that fall into each of the categories. So if you are interested in, viewing and summarizing this category data for a jurisdiction that is smaller than a whole region, this is one way that can be helpful to kind of summarize what's happening with a category perspective for each of these different targets that we have categories for. So I hope that is I hope that's clear, and we're happy to walk through it again. And again, we'll send out these slides so you can see again how to navigate to others, your region, and then viewing the number of sites in each category. And then again, I want to mention the national sequencing plot. So maybe Amanda can drop the link to the national sequencing plot directly in the chat. But if you hover over the colored sections of the bars, you will get the percentage of the variant, and you can see that there's a key over here that shows you all the colors. And these plots use data from the subset of 31 WastewaterSCAN sites that have sequencing data. When you click on location here, it will have a drop down that shows you only those locations that do have sequencing data. And within that list of locations that have sequencing data, one of the locations that there is this all sequencing sites aggregated overview of the sequencing data. So that is how you can access that. If you go to a site that does have sequencing data, that's when this other chart type will appear at the top for sequencing. So that's how you that's how you navigate to the sequencing plots, and particularly to the aggregated one, which gives a nice overview of what's happening nationally that matches quite well with sort of available information on circulating SARS-CoV-2 variants from other sources. And that's it for today. We have time for questions. Our next meeting is going to be March 8th, and you'll get a newsletter from us before then. So yeah, let us know if you have questions. And Amanda has put that link in the chat so you can look at the aggregated sequencing data directly. So Colleen asks, how did you choose the 31 sites for sequencing? That's a good question. So we did a combination of looking at sort of trying to develop a set of sites that would be from around the country so that they would give us a fairly representative overview, and also looking at sort of the populations that are represented at different sites, as well as looking at how well our sequencing protocol performed. So there were actually, other sites that we considered, and we made sure that our sequencing protocol was working really well at all the sites that are now available on the dashboard. So not a perfect science of selection by any means, but doing our best to, without sort of the ability to do sequencing for every single site, choose a network that would be fairly representative. Other questions? You can type, raise your hand, unmute yourself.